1. Welcome to this presentation on waves, senses and light, exploring how nature encodes, perceives, and bends information around us every day. 2. How do waves encode information? Waves carry information by changing or modulating their physical properties. There are three main ways this works. First, amplitude. This is the height or power of the wave. When we change the amplitude to carry a signal, we call it AM. Like in AM radio. Digitally, a high amplitude can mean 1, and a low amplitude can mean 0. Second, frequency. This is how many times the wave cycles per second, measured in hertz. FM radio works this way, and it gives us better sound quality than AM. In digital systems, diherent frequencies can represent diherent symbols, which is called FSK. Third, phase. This describes where the wave is in its cycle. By shifting the phase of a wave, we can encode diherent bits of data. Modern Wi-Fi uses a combination of amplitude and phase changes, called QAM, to send many bits at once. Sound works the same way. Variations in air pressure carry words and music, and light encodes information through its frequency, which our eyes interpret as diherent colors. 3. Which senses do we rely on most? Humans have 5 classic senses plus additional ones like balance and body awareness, but we don't use them all equally. Vision is by far the dominant sense. Around 80% of the information we receive from the world enters through our eyes. Our brain dedicates an enormous part of its cortex just to processing what we see. Hearing comes second, especially for communication. Language, music, and alarm signals all travel through our auditory system. Interestingly, hearing is the first sense to fully develop in the womb, at around 20 weeks. Touch is our most primitive sense evolutionarily, and it's the only one spread across our entire body. It's essential for survival, detecting pain and temperature, and for early emotional development. Finally, smell and taste are less dominant in humans compared to other mammals, but smell has a special connection to memory through the limbic system. That's why a familiar scent can suddenly bring back a very vivid memory. This is called the Proust effect. It's also worth noting that the brain is adaptable. Musicians develop sharper hearing, and people who are visually impaired often develop exceptional hearing and touch. 4. What is refraction? Refraction is what happens when a wave changes direction as it moves from one material into another with a diherent speed. This happens with light, sound, water waves, any kind of wave. Why does it happen? When a wave enters our new medium at an angle, one side of the wavefront slows down before the other, which causes the wave to bend. If the wave enters perfectly straight, it doesn't bend, but it still changes speed. The mathematical rule that governs this is called Snell's law. N1 times sine of theta 1 equals N2 times sine of theta 2. The N values are called refractive indices. They measure how much the wave slows down in each material. Vacuum has an index of 1. Water is about 1.33. And glass is about 1.5. We see refraction all around us. A spoon in a glass of water looks bent at the surface. Rainbows form because raindrops refract and reflect sunlight, separating it into colors. Eyeglasses, microscopes, and telescopes all work thanks to refraction. Mirages in the desert happen because hot air near the ground bends light to make it look like water. And stars appear to twinkle because Earth's atmosphere refracts their light. 5. Who discovered how to send signals with energy waves? This discovery happened in steps, with each scientist building on the work of the one before. James Clerk Maxwell, who lived from 1831 to 1879, was the first to mathematically predict that electromagnetic waves existed. In 1865, he unified electricity and magnetism into one theory and proved that light itself is an electromagnetic wave. His work was the theoretical foundation for everything that followed. Heinrich Hertz, from 1857 to 1894, was the one who actually proved Maxwell right. In 1887, he used an electric spark to generate radio waves in his lab and detected them on the other side of the room. He showed they could be reflected and refracted just like light. The unit of frequency, Hertz, is named in his honor. Then came Nikola Tesla and Guglielmo Marconi, who took this discovery and turned it into real communication. Marconi achieved the first transatlantic radio transmission in 1901, sending a Morse code signal from Cornwall in England all the way to Newfoundland in Canada. He received the Nobel Prize in Physics in 1909. Tesla had actually patented radio systems before Marconi, and there was a long historical dispute over who truly invented radio, a dispute that the U.S. Supreme Court addressed in 1943. In summary, Maxwell predicted the waves, Hertz discovered them experimentally, and Marconi and Tesla showed us how to use them to communicate. 6. Key takeaways. To wrap up, here are the 4 main ideas from this presentation. 1. Waves encode information by modulating their amplitude, frequency, or phase. This is the foundation of all radio, Wi-Fi, and digital communication. 2. Vision is the dominant human sense, accounting for around 80% of our sensory input, followed by hearing, touch, and the chemical senses. 3. Refraction occurs when waves change speed at the boundary between two materials. Snell's law describes the angle of bending, and it explains phenomena like lenses, rainbows, and mirages. And 4. The chain of discovery that gave us wireless communication goes. Maxwell predicted, Hertz discovered, and Marconi and Tesla applied. Thank you for watching.